Hello everyone and welcome to this video. In this program, we will be taking an in-depth look at pointers. We will also talk about how they work and why it is worth understanding them on a deeper level when it comes to C programming. Pointers are a really important topic in programming in general, especially when it comes to concepts such as memory management, arrays, and overall efficiency when it comes to programming. Although pointers are very important to programming, I do not want to overglorify them in this video. So for the format of this video, we will just begin with a simple definition or a statement that tries to summarize what they are, and then we will cover why pointers are important and why they are beneficial in programming in general. Lastly, we will cover an example code in this video as always and highlight some important consistencies with pointers and memory, which I hope will help connect and tie together some of the key ideas we have already covered or you already know up to this point. A pointer is a variable that stores the address of another variable. Very simple and straightforward. When programming, oftentimes we declare variables in order to help us store information or perform a computation. A pointer allows us to store the address of the variable for quick reference. The address of a variable references that variable in memory, and having a way to quickly get to that specific location in memory is what pointers allow us to do. So when you create a variable instead of main or any function, it exists in that scope alone. Remember that C is passed by value. This means if you pass a variable into a function, a copy of that data inside of the variable is duplicated, and then the copy is then passed into the function to be used. That is why you can change the value of the parameters and it never affects the original variable, because the receiving function is just receiving a copy of the value inside of that original variable. And with pointers, you can now receive the location of that variable in memory in the form of its address, so the compiler does not have to make a copy of that variable. This saves space is basically just saves memory. In fact, this is the same technique C uses with arrays. When you pass an array into a function, what you are doing is passing the address of that array to the function. There's no duplication, and this allows C to save space and time. Imagine having to duplicate an array of size 150 every single time you pass that array into a function. That can quickly eat up the memory of your computer and affects the efficiency of your code. So in that situation, you can see how beneficial knowing the location of that array becomes when it comes to programming. Now, I do not want to stretch this video and turn it into a lecture, but there are other ways that pointers are used to make code more efficient with space and time. These include dynamic memory allocation, space conservation, we just went over an example of that, and system level programming and so on. You can do more interesting things like have a pointer point to a function or have a pointer point to another pointer. In later videos, we will cover pointers to pointers because those are easy to demonstrate, but pointers to functions are pretty straightforward. Simply put, they point to code in your program, but its usefulness is fully realized when you have parameters of your function contain void variables, but that is beyond the scope of this video. So that is a few reasons why pointers are very useful to programming, and even if you are not going to use them as much, understanding how they function will make working with variables and objects like arrays very easy. And in fact, that is what we will be doing in the next couple of videos. But in this video, we will just go over a simple program about pointers and how they work and cover some nuances in the code that will help tie topics concerning variables and addresses together. So for the code in this video, you can see we have an integer variable called a, and below that we have a pointer to an integer variable. So the first lesson or note to take is that a pointer, like I said, holds the address of a variable. And with everything in C, you have to tell it what kind of address to hold. Should I hold the address of an integer or the address of a double or character variable? The system doesn't know until you specify what type of variable you are looking to work with. So you have to tell it what kind of variable address to hold. That is why we have the keyword int here. Then we have the asterisk. This helps the compiler know that we have declared a pointer. Without the asterisk, it will just be a variable with the name p. But because we have the asterisk, now the compiler knows that this is in fact a pointer to an integer variable, and then the name of the pointer is called p. One key idea that I want you to understand before we move on is that think of the pointer as a variable as well, but with a few special privileges. We will cover that later on in the video. A pointer just points to a location in memory because it holds the address of that location in memory inside of its variable. So int star p is a pointer to an integer variable, meaning it can point to any integer variable because it has the capacity to do so. If you wanted to point to a double variable, you would just create a double pointer, which will be a pointer to a double variable. So when you see pointers, the best way to think about them is, oh look, we have a pointer to an integer variable, and the name of the pointer is p. Or if it was a double, you would say, oh, we have a pointer to a double variable, and the name of the pointer is p. Now moving on down the code, we have a equals 14. We have seen this 100 times by now. The value of 14 has just been stored in the variable a. Below that, we have p equals %a. This honestly should excite you. I know I was excited when I finally understood this topic because you realize that everything makes sense. Before I explain what this means, let's take a simple look at the scanf function. When you use the scanf function, you are collecting a value from the keyboard and storing it into a variable. And I don't know if you have noticed, but you have to include the ampersand symbol or you get a syntax error. That ampersand symbol next to the variable gives us the address of the variable, and that same symbol appears on this line of code. This should make sense because, like I said, a pointer points to the location of a variable because it holds the address of a variable, and storing the address of a variable allows us to reference that variable directly. So when we say p equals %a, we are now storing the address of a into p, which in turn lets us reference that variable directly in memory. That is a special component that I spoke about when it comes to pointers. So moving on, we have a print statement that prints the integer a and the address of the integer itself out to the terminal screen. One quick note I wanted to point out because it may be a little bit confusing is that in the print function, we have %d, which is this format specifier for integers, right? %f is the format specifiers for floats, %c is the format specifiers for characters, and so on. So in order to print something out to the terminal screen using the printf function, you need to specify the format and align it with the correct variable. We have been doing this for so many times, this should not be new to you. The %p here is the format specifier for a pointer. Any pointer is not necessarily the pointer we have declared here. It is just a format specifier for an arbitrary pointer. It helps us print the address to the terminal screen in hexadecimal format. So don't be confused and think, oh, p is the pointer we declared here in this line of code, because that is not the case. %p in the printf function is just a format specifier for a pointer. Okay, just wanted to point that out. So this line of code will just print the value inside of the variable and the address of that variable itself in hexadecimal form to the terminal screen. Notice that putting the ampersand symbol next to the variable name gives us the address of that variable, similar to the way that we do it in the scanf function. And beneath that, we have another printf function that just prints out the value of the pointer, which we know is just an address, and in order to do that we have to use the %p, and that helps us do that and print it out to the terminal screen. Now the next thing here, which is the $p, is another important concept that I wanted to focus on, because printing out the value of the variable a is nothing new. We would just skip over that. But for the $p, what $p does is dereferences the pointer. Dereferencing the pointer allows you to get to the object that is held inside of the address that the pointer is pointing to. I'm going to say it again. Dereferencing the pointer allows you to get to the object that is held inside of the address that the pointer is pointing to. Hopefully this graphics helps simplify things a little bit. So int $p declares the pointer that can point to any integer variable in memory. Then we pointed it to a. So now p points to the variable a. What is a? A is an integer variable that we have declared, and it holds the value 14. Because we know exactly where A is inside of memory, remember we have A's address stored in P, we can ultimately get to the contents of A very easily. That is what dereferencing a pointer does. When you dereference a pointer, or in this case P, you get the value inside of A, which in this case is 14. I want you to think about dereferencing the pointer as going a step deeper, because that concept will be very beneficial once we cover pointers to pointers. Okay, so star P gives us the value of A, because since P originally held the address of A, the variable A, dereferencing the pointer P allows us to take a step deeper into the variable A, and in doing so, we found the value 14. I hope that makes sense. Like I said, I want you to think about it as just going a step deeper, because just because you dereference a pointer doesn't mean you automatically get the value. Sometimes you can have a pointer point to another pointer. So just think about it as going a step deeper. Hopefully you understand this concept. This is why we are able to use the %d format specifier to print out the value of A, because we are essentially now getting to the value 14, which is inside of A. Remember, storing the address of a variable allows us to reference that variable directly in memory. So when we dereference P, we are basically looking inside of the variable to see what is inside of it, and lo and behold, it is the integer variable which holds the value 14. So sorry if this video took a long time. I wanted to make sure that I gave you a full explanation of the topic, and I wanted to truly paint a full picture around the concept around pointers. There are countless videos that go way more in depth than I did. So if you need more explanation, I think it will be better to reference those videos. But I hope what I had done here at least offered a ground root understanding on pointers, basically a foundation that you can build off from. Again, if you have any questions, please leave it down in the comments below, and I will be sure to answer them. Thank you for watching. Like this video if you found it to be useful, and I will see you in the next video. Thank you and bye.